Okay, so I'll continue doing this. So this is lesson number 40, okay? And it says, how do we play with a big circle? All right, so let's talk about the big circle. It says, a big circle question combines all or most of your circle angle formulas into one question. You may also need to apply other strategies to find all the missing angles. Of course, and we are going to use different strategies and different approaches and shortcuts to come up with all the answers. So let's read what it says. It says, circle O, okay, a circle is named by its center. It has with tangent DE and measure of arc BC, well, and arc BC, CD, AD, AB in a ratio of 7 to 8 to 12 to 9. So how are we going to tackle this? Well, we still don't have a question. It says find all the numbered angles. Okay, now we have a question. So, wow. Let us first, okay, we don't know how to find the angles. We don't know if these triangles are equilateral or not, but look at the ratio, 7 to 8 to 12 to 9. I told you already that whenever you have something in a ratio, just put a variable on it, add them up, and equal them to whatever the total is. Well, we're talking about arcs, okay? We're talking about arcs, look. And we know that all these arcs form the circle, and the circle has 360 degrees, so that's exactly what I'm gonna do. So I'm gonna start with, let me see if I can zoom in. Let's forget about the circle for a second. So I have 7x plus 8x plus 12x plus 9x equaling to the total number of degrees in a circle, which is 360. All right, so when we add this, we get 36x equaling 360. Now we divide by 36 on both sides and we get x equal 10. Of course, I didn't have to divide. All I had to do was like 36 times what, okay, is 360 times 10. Okay, cool then. So let's see now. BC, CD, AD, AB. 7, this is 7x. I'm sorry. BC is 7x. Okay. CD is 8x. The next one is 12x. Okay. 12x. And this one is 9x. Okay, cool, right? Let me make the circle smaller, but still, hopefully you'll see everything. Okay. So, this arc AB measures, the measure is 90 because 9 times 10 is 90 because we know that x is 10. 7x, then this is 70. Then this one is 8x, so this one is 80. This one is 12x, so this is 120. Okay, so that's how I found my measures. So let me delete this now that I know. Okay, cool. Now let's start finding measures. So I wanna, first of all, you could start anywhere you want to as long as you know what you're doing. Look, this is an inscribed angle right here. The intersection of the angle, okay, or the vertex of the angle is on the circle. So an inscribed angle measures half of the intersected arc. So this is the intersected arc. So this one is nothing more than 60, okay? Maybe I should use a different color marker or whatever, I'm not sure. Let me see if I do. If I have, I'll do it. So this is 60. Okay, better? Cool then. Now look at this. Angle number 3 intersects 70. So angle number 3 is 35. Okay? Now what else? Okay, angle number 1. Intersected arc right here, look. Angle number 1 intersects 80, so angle number 1 is 40. Alright, did I run out of numbers? Well, let's see now. Let me find angle number 4. How do I find angle number 4? Look at this. This is a triangle. A triangle has 180 degrees. Right? So all you gotta do is You add 60 plus 35, which is 95, I hope, right? And now you take that away from 180. So angle number 4 is 85. Because angle number 4 and angle number 6 are vertical angles, okay, you see that? Then angle number 6 is also 85. Now, because this is a straight line, you see how I'm playing this game? This is a game, you gotta figure it out. Because this is a straight line, then it measures 180. So the measure here is 95, because 95 plus 85 is 180. And then since 5 and 7 are vertical angles, then the measure of 7 is 95 as well. Okay? Alright, what else? And by the way, I could have used different approaches if I wanted to. For example, this time I want to find the measure of angle 12. Well, look at angle 12. Angle 12 has an intersection outside. This is the intersection outside. And it cuts this angle of 80. And it also goes all the way here to cut the angle of 120. When the intersection is outside, you subtract the numbers, okay, the arcs, the measure of the arcs, and divide by 2. So I am going to have that angle 12, I'm gonna put it right here, angle 12 equals the measure of this arc 120 minus 80, okay, that's 40, and then I divide by 2. Okay, let me make it different, divide by 2, and now 40 divided by 2 is 20, so angle 12 is 20. Cool then. Now, can I find the measure of angle 11 right away? No. Or maybe, nope, I can't. But, can I find the measure of angle 10? Well, look at angle 10. The intersection is outside, and it cuts this arc. It also cuts this other arc. See that? Okay. Or, look at this. I could find angle number 9 if I wanted to. Angle number 9, look, cuts, the intersection is on the circle. And it cuts this arc of 150. So, half of 150 is 75. So angle number 9 is 75. And you know what? I didn't even have to do that. That's so crazy because I can see that this is a triangle. So 85 plus 20 is 105. Plus this will be 180. Because this is a triangle. So you see, there are many approaches. Now, let's see. What else can I find? Anyway, let me find angle number 10. Because I don't see, is there another way to find angle number 10? Nope, not really. Okay, so angle number 10. So angle number 10 cuts this arc and it cuts this other arc. Wow, that's crazy. Guys, I don't need to do that. I was gonna subtract, right? I was gonna subtract 210 minus 80 and divide by 2. But look at this, I just figured out that this, where was it? This is a triangle right here. See that? So I got 75 plus 40 is 105, right? Or 115. What is it? Is 115. Okay. So the sum in this triangle is 180. So if this is 115, the sum of these two is 115. Then this angle 10 must be 65. And now, because this is a straight line, then angle number 11 must be 115. Am I missing something? Oh yes, I'm missing angle number 8. Okay, so watch this. 1, 2, 3, 4 sides. 4 sides means 360 degrees, and I got 85, 75, and 65. Okay. So 65 plus 75 is 140. All right. Now 140 plus 85. 140 plus 85 is 225. From 360, you have 135 degrees left. Of course, all these must be degrees, 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 and so on and so forth. Okay. And I think we completed the, yeah, we completed the big circle. Wasn't that bad, right? Okay then, by the way, we could corroborate all this in here. Here you have an explanation of each of the things that we found. So for example, here we found the measures and we figured out that x was 10. So then all the other arcs, all the measures of the other arcs are right here. Then look at this, angle 1 is 40, that's nice. 35, wait, angle 2 is 60. Wait, hold on a second, angle 2 is 60. Oh yes, angle 2 is 60 right there, you see that? That's cool, right? Alright. Then you have the other measures. Angle number 685. And basically here, when I did this explanation, I might have taken a different approach. But the measures are accurate. Okay then, so now let us move on to, were you careful to use all of our, okay. So now we have a different circle. We have it right here. Guess what? The big circle. Find all the measures. So how am I gonna do this? Easy. First, I need to know what the ratios are. So, arc SN is 60 degrees. You cannot see it. I'm gonna make sure you do. Okay. So, measure of angle NS is 60. So where is NS? So NS is 60. And we're talking about the arc. QS is X. That doesn't help me. Okay, QS is X. Then we have QP. QP at X plus 40. Then we have PN as 2X. Okay, so you know what I'm gonna do? I am going to add, I could do two things. Add them all up and equal them to 360, or just add this and equal them to 300, because I already know this is 60. This is 60. So which one you want me to do? I'll just add them up and equal them to 300, excluding this one. So I have, and I'm gonna write with a pencil because even though I'm a math teacher, I make mistakes. So X plus 40 plus 2X minus 16 equals 300. Add the like terms. X plus X is 2X plus 2X is 4X. 40 minus 16 is 40, 30, 24. And that equals 300. Now I am going to subtract. I'm going to subtract 24. So I get what, 276? Okay. So 4X equals to 276. Okay. Then I'm gonna divide by 4. You already know that. So I get X equals 69. Good. X is 69. So now I'm gonna plug this into the arcs that have variables and find my measure. So QS is X. QS is X. Let me go here. Let me find QS. QS is X and X is 69, so this arc is 69. Okay. QP is X plus 40. 69 plus 40 is 109, right? So QP is 109. QP is 109. QP is 109. PN is 2X minus 16. So what is 2X? 2 times 69 minus 16. Well, that's 122. So PN is 122. Alrighty, now I'm gonna make this smaller and we're gonna start working our way through the big circle. Okay, so measure of angle 3. Measure of angle 3 is an inscribed angle and it cuts 109. So half of 109 is what? 54.5. Now, let's see. Let's take a look at angle 5. Angle 5 cuts 69. See that? And it's an inscribed angle. You see that? Good. So then, measure of angle 5 is half of 69. So that will be 34.5. Okay? 34.5. Now, measure of angle. Okay, I could do so many things. In this case, I am going to try to find the average. Let's find angle 11. So angle 11 cuts QP, which is 109. Okay, so angle 11 cuts 109, but also, okay, also the intersection. I'm looking at the intersection. Okay, so 109 and angle 60. So I'm gonna have 169 because the intersection is inside. I have to add the arcs, correct? So I get 109 plus 60, that's 169 divided by 2, and that is 84.5. So angle 11 is 84.5. Okay, and if angle 11 is 84.5, then angle 9 is 84.5. This is a straight line, so that's 180. So if this is 84.5, then this one is 95.5. And this is also 95.5 because they're vertical angles. Okay. See, I'm not using too much the idea of the triangles up until now. I'm gonna start using the idea of triangles. So, if I have, let me see, how did I find this to be? Oh, angle 6. Wait, angle 6 cuts the arc that is 122. Okay, that's very good. And it's an inscribed angle, so this measures half of it. Okay. Let me see now. 61. Let me see. 4.5 plus 4.5 is 10. 9, 10. Yep, 180. Okay, okay. Just wanted to make sure. Okay, angle 7 is half of 60. You see that? Angle 7 is 30. And I still haven't used the idea of triangles. I need to use it because I'm not gonna be relying on that. So I could say that angle 4 is half of 60, which is 30. But let's use the idea of the triangle. The triangle has 180 degrees. So if we add 95.5 plus 54.5, we get 150. So therefore 30 degrees is the correct choice. Alright, what else? Angle 2. Angle 2 is on the circle. So it's half of the arc it cuts. Well, angle 2 cuts this arc right here. Okay, so what is 60 plus 69? That's 129. Half of that is 64.5. So, oh yeah, angle 2. Angle 2 cuts this arc, 169. So half of that is 64.5. Now, to find angle 1, I could do two things. Since the intersection is outside, okay, angle 1, the intersection is outside, then I have to subtract the arcs that it cuts. So that will be 60, and that will be 122. See that? Well, and then after I subtract them, I divide by 2. That's one way. The other way is nothing more than looking at the triangle right here. See, 84.5, right? Then you have 64.5 right here. So add them up. So you get 149. And you know that a triangle has 180 degrees. So this is 31. Yes? Okay. Am I missing anything else? No, I think I found everything. Well, if I missed it, then it's your responsibility. Okay, so we got this. Let me just give you a quick review, not a quick view, sorry, of the circle. So angle 1, angle 2, angle 9, the arc. Then you have this, and I just realized that I didn't find angle 12. It doesn't matter, look, I got 30 and I got 95.5. So I just do it. So I get 125.5, then subtract from 180 and I get 54.5. Perfect, right? Okay then. Please tell me I didn't miss anything else. No, I think I got everything. Alrighty. So now let's see what we have here. Oh, we got one last triangle. I mean, yeah, well, this is a big triangle right here. But we have one last big circle. All right. So you have the arcs. Okay, AU is X. Okay. AU is X. Then UG is 2X plus 20. So 2X plus 20. You know why I'm putting them like this? Because I already know what I'm gonna do. GN is 3X minus 40. 3X minus 40. NA is 4X minus 20. Okay? You know I'm gonna add them up, right? And equal them to 360 because that's a circle. So X, 3X, 6X, 10X. 10X. Now 20 minus 40 is negative 20. Negative 20 minus 20, it's negative 40. So minus 40 equals 360. Add 40 to both sides. And you get 400. Divide by 10 and you get 40. So X is 40. So now all I gotta do is put the measure of each of the arcs. So arc AU was X. So AU was X. And since X is 40, then AU is 40. Then we have angle UG right here, which is 2X plus 20. Let me see. I'm sorry, I'm gonna make this smaller, but it's for our own benefit. So this is 2X plus 20. Well, X is 40, so 2 times 40 is 80, plus 20 is 100. Okay, now GN. GN is 3X minus 40. 3X minus 40. X is 40, so 3 times 40 is 120 minus 40. 120 minus 40, 80. Okay, and finally we have NA, which is this one right here. Okay, NA was 4X minus 20. So 4 times X, which is 40, so 4 times 4, that's 16, so 4 times 40 is 160. 160 minus 20 is 140. Okay? Okay, cool then. Now we can start playing the game. So, let's start going at it. So, this right here, let me see. Okay, this right here is angle 10. You see, angle 10 is an inscribed angle, or you could say that the vertex is on the circle, the intersection is on the circle, whatever you do, you know that the measure of the arc is going to be double the measure of the angle. So the angle is half of the arc, so the 10 is 50. Okay, then we have G. Look at G. It cuts 40, so G is 20. Look at 3. 3 cuts 140, so 3 is 70. Look at this one. It cuts 100, so this is 50. 11 cuts 40 as well, so 11 is 20. 6 cuts 140, so 6 is 70. Remember, if the angle was a central angle, like coming from the center like this, then it would have the same measure as the arc, but we're dealing with inscribed angle, so the measure is half. All right, so this is as much as I'm going to do. I hope you understood the idea behind it. Okay, hope this was helpful, and this is the end of lesson 40. Wasn't that long, right? Okay, cool then. I'll see you on lesson 41.